we starting part 2?
No, not yet. I think we're getting like part 2. Is that what you're asking about?
Yeah.
Yeah, we're getting ready to. All right. Hopefully you've had just a second to look at the top part 1, like 1 through 6. If you haven't finished it, you just need to go back and finish it when you can. Okay. I am going to go ahead and look at part 2 though, because now we're going to be dealing with 2 systems working together. So 2 systems working together. Let me go ahead and get my screen set up here. Okay. All right. So here we go. So we know that you can calculate heat of a system by using that MCAT formula. It's what we call it for short, right? M times CP times delta T. It looks like MCAT. All right. So you can use the formula for MCAT to find heat of a system. So what if you're dealing with 2 systems though? What if you're looking at water, for instance, as one system and we're looking at metal as the other system? You take a piece of hot metal, you put it into water. Can you calculate the total heat exchanged if you know some information about both systems? And the answer is yes. We know that Q is equal to negative Q, okay? So heat gained by one thing must equal heat lost by something else, right? Because of the law of conservation of energy. Energy is never destroyed or created. It just changes. Like it can change into different types of energy and it can move in and out of systems, okay? From a system into surroundings and vice versa, okay? So having said that, if we know that Q is equal to negative Q, couldn't you also say, sorry about that, couldn't you also say that those formulas are equal to each other? Couldn't you say that if you know the mass times CP times delta T, it would be equal to negative mass times delta T, whoops, times CP, whoops, times delta T. Right? Heat in must equal heat out. And so if you know these things, we could set up a problem and solve it, even if we had 2 systems that we're looking at. You could look at the whole, look at the thing as a whole, okay? Which is what we're going to do. The way that we're going to approach part 2, though, is since you're dealing with 2 different things on these problems, we're going to set up 2 sides of our equation. We're going to have the heat in side, and we're going to go have the heat out side, like the heat going in, and we're going to have the heat going out. So we're going to set up 2 sides of the equation based on this formula, okay? So take a look at problem number 7, okay? So problem number 7, it says that you've got a 155 gram sample of an unknown substance that was heated from 25 to 40 degrees Celsius. It was then dropped into 250 grams of water that had an initial temperature of 22 degrees Celsius. Now, after a few minutes, the water reached a maximum temperature of 26 degrees. What was the specific heat of the unknown substance? The specific heat of water is 4.184 joules per grams degrees Celsius. Holy cannoli, that's a lot of numbers, right? So let's do some sorting, right? Since you have 2 substances that we're looking at, we're gonna set up a side for both. All right. Let's have our unknown substance and let's list all the information we know about our unknown. Do we know the mass of the unknown? 155. Very good. Okay. What else do we know about the unknown? Yeah, the change in temperature, right? You know the change in temperature, the delta T was final minus initial. The final temperature, where did it land? 40, right? So 40 minus 25 would be 15, right? So 15 degrees Celsius is our change in temperature, okay? So that's all the information that we know about the unknown, okay? It says then, it was then dropped into 250 grams of water. So over here, I'm just gonna make a water side. Make my water side. Got 250 grams of water. Lord, it's weirding me out. 250 grams of water that had an initial temperature of 22 degrees Celsius. So I'm going to put my delta T. The initial temperature was 22. The maximum temperature, I don't know why I did that. The maximum temperature was 26. TF minus TI. What was the specific heat of the unknown substance? Okay, and they tell you the specific heat of water is 4.184. Okay, and so they're looking for the specific heat of the substance. We don't know that. All right. So what are we going to do at this point? Let's plug it in, right, and solve. Okay. Now, I think I've already screwed myself up, though. I'm pretty sure I have. Good? Yeah, all right. Okay. Is your nose bleeding?
No.
Okay. All right. Good. Okay. All right. I think I've already messed myself up. So I'm going to have to redo. Okay. The final temperature of the system should be the same on both sides. Because if you drop a hot piece of metal into water, what's going to happen to the hot piece of metal? It should cool down, right? And so I've already got myself screwed up. So I'm going to go back and fix this. The metal was heated from 25 to 40, but when it was dropped into the water, it was 40 degrees Celsius initially. Okay. And then it reached the final temperature of the system of water. So I'm going to go back and fix this. It's not going to make a huge change, but we know that the temperature of the metal started initially at 40. And the final temperature of the system, they told us that the water ended at 26. So this is TF minus TI. Okay. So what's my final temperature change here? 14 and negative 14, right? Okay. And if this side is negative 14, then, and if we know that what's going to happen to the unknown substance, was heat going, when you drop that piece of metal into the water, was heat leaving the unknown or was it going in? It was leaving, because that metal, when you drop hot metal into water, it's going to go and it starts to cool off. Heat leaves the metal. So this is going to be our negative Q side. What happened to the water when you drop that hot piece of metal in? Yeah, okay. It's going to heat up. Heat goes into the water. So that's going to be our positive Q side. So you do want to ask yourself some of these questions before you get started. Now at this point, we can start plugging stuff in, okay? So I'm going to go down here and I'm going to start to set up this side. If I know that this is my negative Q side, I'm going to go ahead and say negative times the mass, which is 155, times my CP, which I don't know, times my delta T, which is negative 14. Okay? Everybody with me so far? Okay. I'm going to set this equal to what I know about my water. So I'm going to say 250 times my specific heat, which is 4.184, times my delta T, which would be what? 4. Okay, because we know that 4 degrees Celsius. Okay. So from here, again, it just becomes an algebra problem. Okay, do your order of operations. You would multiply, I would go ahead and multiply everything on the right side first. Let's see what we get here. Okay, I got 4,184. I'm going to set that equal to, I'm going to take 155 times negative 14. And because of the fact that you're multiplying it by a negative 1, basically, what does a negative times a negative do? Makes it positive, right? So whenever you take this negative times this negative number, it's just going to become a positive 2170x. Okay. And so at this point, how do you solve to find x? Yeah, divide both sides by 2170. Okay. And you end up with x equals 1.93 is what I'm going to do around there, 1.93. What are the units for specific heat? Yeah, joules per grams degrees Celsius, right? Because it's the amount of heat needed to raise 1 gram of that substance by 1 degree Celsius. So the units really are joules per grams degrees Celsius. Okay, that's the specific heat of our unknown substance. Okay. I will probably do one more problem that you can look at later if you want to get online. But otherwise, that's how you're going to do all of these problems on number 2. You just look to find the unknown. Like whatever it is that they're asking about, you let that be your X and solve it. Okay? All right.
There might be too many variables for number 8.
Number 8. Got a bunch.
Piece of gold, as you can see, we have the specific heat of gold. We don't have the grams of gold, but we also don't have the temperature.
Oh, yeah. So,
I don't think that's all.
whoops. Yeah. Hey, let me look at that one, and then I'll fix it by 3rd hour, and I'll send out a remind because I've got to do the math there to make sure it works out. Okay. All right. So skip number 8 for now, but it will be corrected after 2nd hour. So maybe. Oh, hey, so these will be due on Wednesday. Okay. You're going to have it ready by Wednesday. Tomorrow we're doing a lab. So